Hi everybody. If you've ever been wondering how simple commands in Linux actually work under the hood, I think this is the right video for you. Because in this video we're going to try to code one of the simplest Linux commands ourselves. And that is the echo command. You all know it. Let's echo something to the console. Hello world. That's the echo command. It just accepts arguments, in this case one argument because it's a quoted string, and outputs that to standard out. What is it even used for? In practice, it's, well, for beginners, of course, to do this hello world thing. Then you can pipe it into a netcat and send a message somewhere to some TCP server, for example, netcat. Let's open a small TCP server. This is just a machine waiting for TCP messages. And now you can use echo to pipe this message into a client that connects to the server and sends the message down here, as you can see. So you can use echo for all kinds of things. There's an unlimited number of use cases. And I think there's quite a lot of value in creating echo ourselves. So let's create a directory and call it echo. And I will create a source code file that's called myecho.c. And at the end of this video, I want to have my own variant of echo. It should be as close to the actual echo as possible, if not unmistakably similar. And this is ideal for C coding beginners, for example, learning some basics about the C language, Linux, streams, and what else there is. So let's create a small source file and include standard.io.h. Let's create a main method that has a number of arguments, argc and argv. argc is the argument count, argv is the argument value array, and I think this should be it for the arguments for now. And what the echo command does is it accepts any argument, for example, this world string right here, and prints it to the console. Now, it also accepts multiple arguments, so that's something we have to consider. So we can also write something like the world is big, and it prints those to the console. But now you have to pay attention because those are separate arguments. This is not a single string. This is a set of, or a sequence of 4 arguments. And you can show this by separating those with spaces. And as you can see, the output string is just delimited by a single space every time. So this proves that the bash shell parses those as individual arguments and forwards them to the echo executable. Yeah. If we want to print something with spaces, you can just put it in quotes, of course. And now the string is put in quotes. The string is spaced out. And that is because if you put something in quotes, it is assumed to be a single argument. Yeah. So what you have to do in the executable is technically just accept the arguments, loop over them, and print them all to the console. So I don't think it should be that hard, honestly. And maybe one more test. I don't think we can pipe something into echo, can we? What happens if I pipe hello into echo? Yeah, nothing. So yeah, this just outputs hello. No, this just outputs world. So this is the second echo statement. So echo ignores anything that is input to it via standard output. It accepts only inputs via the argument list. It ignores standard input. Alrighty. Now, this is probably going to be super simple, and since I'm a C beginner, I consider myself a C beginner, this is going to take more time than some of you viewers out there probably like. But let me just start with something. So we loop over the arguments. So for int I equals 0, starting at index 0, while I is smaller than the argument count, we loop over the input arguments. However, let's print them all to the console using printf. And yeah, one more detail, since the echo is accepting arguments, hello, and then world, as you can see with spaces in between, it outputs those arguments with a space in between the words. So we have to put a space here between the arguments, I think. And then we access the provided argument values array at index I, and this will probably work partially. Let me just go into the projects directory and then in the echo directory where we put our myecho.c file and compile that. I will also enable all warnings and the debug flag and even pedantic. This just makes sure that it outputs all the possible warnings about my source code, because I don't want to overlook anything, especially not when recording a video. All right, so the output file is going to be called myecho, and the input file is myecho.c, and this compiles the file. We get no warnings, which is a good sign, even though we enabled so many flags here to output all warnings. And let's try to execute myecho. And it doesn't do, it does something, even though we supplied no argument. It prints something to the console, and this is because the first argument to an executable, or rather the 0th argument, is the name of the program that is currently being executed. So if you execute myecho with arguments, let's call the arguments first, second, third. Then, since we loop over all the argument values and the 0th argument value that is passed to the main method is the name of the executable, because of that, it outputs itself as well as the arguments, which we don't want. But overall, let's clear this again. The behavior, let's check the behavior if it handles the spacings well. First, second, and third, and those are separated by quite a bit of spaces. And as you can see, it outputs those with just a single space. So those input arguments are properly handled. We just have to skip over the 0th input argument. So we can just start by looping. We can just start looping at index I, which should skip the initial argument. So let's try that, and I haven't compiled yet. Let me just compile this. Where's my compilation command? There it is. And let's execute myecho first, second, third. And there we go. It outputs the arguments to the console. Now just the only thing that is, well, there are two things that are bugging me right now. There's a space at the end of the printout, and there's no new line, because if we do echo first, second, third with the original echo, then it outputs those on its own line. And I don't think there's a space after the last argument. So how do we do that? We can just keep it. Oh, what's that? We can just printf a new line at the end of the execution. Let's see. So let's compile and execute myecho. with first, second, third. And as you can see, the output is now first, second, and third. It looks the same as from the original echo, and it feels the same. What's bugging me is just the space that is hiding here at the end of the third. But we can even check cleverly whether the original echo leaves a space at the end of third. Let's try the following. We echo first, second, third into MD5. MD5 is a hash algorithm which takes as input data and gives us a unique string that identifies the data. It's not MD5, it's MD5 sum. And that string is now 14BB0C, etc. All right, let's try MD5 sum with our own echo command. And as you can see, it's not outputting exactly the same data. So the identifying string is different. This is not outputting exactly the same data as the original echo. And I suspect it's because of the trailing space. So we have to get rid of that. How do we get rid of it? I think a simple solution would be to eliminate the space here, and if the index I is equal to argc minus 1, so it's the last printout that's happening, then it prints. No, if it's not the last argument, then we print a space, and else we don't do anything. So let's print a space here. And for if I is the last argument, so I is equal to argc minus 1, then we print no space. The if statement is skipped over. Let's see. Does this compile without any warnings? Yes. Sometimes I'm not sure if I use the if statement without the braces, but this time it seems to be fine. So let's execute myecho now with first, second, and third. Looks fine. What if we pipe it into MD5 sum? Yeah, that's it. As you can see, we now have the same output hash as the original echo, which means that our own echo command is really formatting the output in exactly the same way as the original. And we can just do another test. Let's do something more complex. Let's echo a couple of special characters, a couple of spaces, queen, and then first separated by many spaces, and then second. So this is quite a complex task now. And it outputs the first argument formatted, as you can see here, including the spaces. Then the first string here, and then it ignores those spaces and outputs just one space, and the second string here. Okay, and to get an identifier over that output, to be very sure that we generate the same thing, let's put that into MD5 sum, and it generates this identifier here. And let's try to invoke the same command with myecho, and the output looks like this. And let's see if the identifier is the same, MD5 sum. And indeed, this is exactly the same identifier. So in this case, it works. I think the echo command has just one small detail that I want to include in this video. If we do echo and then we echo something, let's say first, second, and we add something here. I think it was -c. No. What was it? -l, -n. No. I was calling myecho. That's the wrong echo, of course. Echo -n first second. Yeah, that's the option I want to also include. If we invoke echo with -n, then it prints out the stuff that we want to print out, but it appends no new line character, so there's no line break at the end. And that's useful for a couple of use cases where you just want to write stuff in a single line. For example, if you want to do successive echoes while something is processing. There are applications, otherwise there wouldn't be this option. So let's try to include the handling for this option as well in our C source file. And I'm not sure how to properly process options in C. We could do something like int enable newline, and that variable is 1 if the new line is enabled, or it's 0 if it's not enabled. Or we could name it disable new line, because the default behavior is that the new line is enabled. So if nothing is specified, then the new line is enabled. Disable new line is active if the first argument, if argv1 is equal, and for that we can use a string compare. It's, I think, in standard lib. I don't know exactly, so let's open a man page, string compare, and it's part of string.h, and that is a method that compares two strings. And it's 0 if the strings are equal, and something else if the strings are not equal. So we have to include string.h, and then so maybe for this example, enable would be more useful, because enable would be 0, so false, if the strings compare, if the string comparison is resulting in identical strings, and 1 or a non-zero character in any other case. All right, so we compare strings with that, I think that, and that could be a constant even. Constant character pointer new line option. Let's call it new line option, nl opt, and that is -n. And if the first argument is the new line option, then enable new line is 0, because the strings compare and are identical, which assigns them the value 0. So if enable new line is 0, then we skip this statement here, this print statement, and if it's not, then we append a new line. All right, that might already do it. I'm just worried about the for loop now broken, because the first argument is now an option instead of the input strings. So we have to adapt this. If an option is specified, then we shouldn't start from integer I equals 1, but from integer I equals 2. So if enable new line, let's call that, oh god, wait, I is equal to 1 if enable new line is false. And so if enable new line is true, then the starting index is 2, or alternatively it's 1. All right, I think the spaghetti code is done. I hope, I'm not sure. And let's give this code a bit more space so that we have a good overview over what's going on here. All right. So that's the full source code. Let's try to compile it and see if the compiler is even complaining about anything. No, it's not, which is quite surprising. And yeah, I'm not sure if that code is hard to read. Please, everybody who's a pro at C, please put it in the comments. I've heard of the concept of write-only code recently, which was written once but never supposed to be read by someone. Maybe this is write-only code and not read-write code. Anyways, so I'm trying to invoke my echo with arguments first, second, and third, just as we originally tried, and it's skipping the first argument. So this is already a bug. So why is it skipping the first argument? Enable newline is false because the option is not specified. No, the string comparison is returning a true-ish value. That's so confusing. Can we invert that? If not, enable newline. Maybe like this. So if we enable the newline, then the starting index is 2. No, wait. Maybe it should be 1 and the other one should be 2. Let's try again. I think I just inverted the entire logic and therefore I have the same resulting behavior. So enable newline is... Okay, wait. The first argument that we pass in is first. First is not the same as this option here. So the result from the string comparison is a non-zero value. If I negate that, I would expect a 0 value, but maybe that's wrong. It probably doesn't work because we're dealing with integers and not booleans here. So I'm probably a bit confused by other programming languages. So now we print first, second, and third. The first argument is passed. It's not the same as this character, therefore the string comparison returns something non-zero, which means that enable newline is active. Yes, it's active because it has not been disabled by this option. And if it's enabled, then we should start printing out the arguments starting from index 1, else starting from index 2, because the first argument is the option and not an actual positional parameter that we want to print to the console. All right, so this works. If we enter spaces here, this still works exactly the same as the original echo. And then the magic question is whether we can use the -n option now. First, second, third, maybe even with some spaces. And as you can see, it works. I think there's just one culprit here that I haven't covered, and that is if I specify no argument, then we get a segmentation fault. And that is because we do a string comparison over the argument value entered at index 1, which is of course not filled. So this is acting on memory that is not existent. So we have to do a check for the argument count. Maybe here. So argc, well, argc equals 1. Or let's say it's smaller than 1. It doesn't matter because it's impossible that it's smaller than 1, I think, if no arguments are provided. If no arguments are provided, then we do then we do just nothing. What does echo do if we provide no arguments? It prints an empty line, and echo-n prints nothing. Okay. So argc is smaller than or equal to 1. That means we... Well, on one hand, we have to skip the enable newline check. On the other hand, we have to still print the new line. And that is what's confusing me right now. So let's check argc. If it's smaller than or equal to 1, then we should just skip. Then we should just skip this string comparison check. Right. Okay. We created an integer, options available, and that equals argc smaller than or equal to 1. So if... No, it must be bigger than 1. So if the argument count is bigger than 1, that means that options are available? No, that's also not true. Wait. If no arguments are provided, if there's just a single argument, so argc is 2. Let's do it simply. Let's just write out some if cases. If argc equals 2, then we can check. Then we can check if this single argument is the newline option. Enable newline. I'll create a variable for that here, and we'll give it a value here. If argc equals 2, then we check whether that is the option. And then we print f nothing to the console. We just exit with a success error code. That's fine. Standard lib. It's coming from standard lib. So no, we have to check if the first argument, if the argument count is 2 and... Oh god, what? I'm not sure if I'm really writing the simplest possible code here. If the first argument is this, is the newline option, then we say enable newline has this value, and no, then we just exit. I feel so stupid. Okay, so we are checking the first argument. If it is equal to the -n, then we just exit because we don't do anything, just like the original echo. So echo -n does nothing. If we specify no argument, so if the argument count is equal to 1, then we do... What do we do then? We just printf a new line character. And in any other case, so either the argument count is 1, in which case we just print the new line, or the argument count is 2, in which case we check if that argument is the new line option. If it is, then we exit right away to not print anything to the console. And if the argument count, basically it's an else here, but we don't need to write it out. If the argument count is bigger than 2, or it's 2 and this option is specified, then we just do the rest of the processing. String compare. It's always, by the way, it's always the case that things are super simple to program until you have to parse options and arguments and have to somehow unify this into some combined behavior. I have no idea how to properly do this in C. As you note now, I'm struggling with a single option. But I just want to get this working. And I think it's quite nice to learn some basics here anyways. So let's try to compile that and execute it with the new line option. Disable new line. By the way, I keep saying new line option, but it actually disables the new line. So this prints out the first, second, and third argument, ignoring the space separations. If we put all of that in quotes, then it will print out accordingly as it did here. Perfect. Now we should also check if myecho can handle no inputs. No, it can't. And that's because we have to exit after this printf statement here. Printf this. Can we maybe even do an exit inline here? I don't know. Let's try. I don't think we can. I think this is giving me a warning if I compile this. GCC. Yeah, it is. Yes. As you can see, and that's why warnings are super important. The warning is telling me this statement, blah, blah, blah. The letter is misleadingly indented as if it were guarded by the if, but it's not. It's not part of the if. So let's go up here and fix up the guards. Exit. Okay. And let's try again. Let's compile. No warnings. And now we can just try to echo something with the disable new line option. Now let's try to echo something without the disable new line option. That doesn't work. Is the argument count... Did I mistake the argument count somehow? If the argument count is 1, maybe if it's 0, but then I also have to fix up this. Okay, let's try again. Let's compile. Okay, this single argument echo works. If I append the disable new line option, does it still work? Yes, because now it prints that string out without the new line at the end. And let's try to echo something without any arguments. Segmentation fault. Why? The argument count is 0, isn't it? I think it's time to hop into a debugger. So to do that, I'm going to go into the projects directory, echo OpenGDB with the myecho source file. And this is quite a valuable opportunity to check out the debugger. I love debugging stuff. Let's switch layouts. Hey. There's the source code. And now we can put a breakpoint in line 8, break 8. We can run the software. And as you can see, the argument count is 1, even though I didn't specify anything, because argv at index 0 has the value of the program name. Yeah. So the argument count is always at least 1. But I'm surprised why this creates a segmentation fault down here. We've just compiled this and we are executing it. Huh? Did I just forget compiling? It seems to work now. But this is the same behavior as echo. We can improve it by piping it into MD5 sum. It results in some MD5 sum result, and our original echo outputs the exact same thing here. So that seems to be working. Now, what if I do echo first? Or I am the king of the world. That outputs I'm the king of the world. Let's try the same with the -n flag, outputs that string without spaces or with just single spaces as delimiters to the string without the new line at the end of the console, of the terminal output. And now, so the execution without any arguments seems to have worked. What if we put a space here? Still seems to work. If we put a new line here, seems to work. We can pipe that into MD5 sum and just compare it with echo-n MD5 sum just to prove that it's the same thing. It is the same thing. It's basically, yeah, this is proving that the output is identical. I think this could be it. So let's just do the super ultimate test. Myecho zebra horse. My life 8 is and let's put a couple of special characters in single quotes here. This is the output string. Seems to be properly formatted. Let's compare it with the original echo. Okay, looks the same. Let's pipe it into MD5 sum. That's the output. And let's pipe the original echo also into MD5 sum for comparison, and it's the same hash. And now as a final test, we have to just pipe that string with the disable new line option into MD5 sum. It gives us this hash, and the original echo for comparison gives us this same hash. All right, and that's it. We now have our own clone of echo, and it's doing exactly the same as the original echo. Yeah, works. So myecho. Thanks everybody for watching. Yeah, awkward pause. And yeah, that's how you code your own echo implementation yourself on your own. It's actually quite simple. I hope you enjoyed it. And if you did, then stick around and see you next time. Bye.